Hello, YouTube. This is Jay Coder. I'm back with another stream, and today is going to be a bit different. Today we're going to go over a couple videos about Jetpack Compose, and I'm showing you guys this video to help set the foundation better on Jetpack Compose before we start diving into more coding in it. We did before the previous streams, we worked on a chat app in Jetpack Compose that basically showed how to set up a UI with Compose with a chat interface. And now we're going to dive deeper today, going over these videos. And so during the stream, I'm going to go ahead and show you the video, and I'll comment on it as well. Any comments that come to mind, I'll comment on as well. But my main goal for today is, I think it's important information for you guys to take a look at. And so, yeah. And if you like this kind of content and you like learning about Android and technical things and also programming, please go ahead and subscribe to this channel and like this video, comment on this video, do all of that. And I thank you all for being here today, and I'm not going to take too much of your time. I'm gonna go ahead and get started. I'm gonna go ahead and mute the music there, and I'm gonna share this link here in the chat so that if you guys want to check out the website yourself, you can. I'm getting this information straight from the developer.android.com so that you guys can get the most quality of resources coming straight from the source on best practices. And so, yeah, I'm gonna go ahead and post that link in the chat just really quick, and I got that posted there. All right, now I'm gonna get started. So the first video that we're going to be looking at today is called Thinking in Compose. And so I'm gonna go ahead and start the video for you guys. So yeah.
Jetpack Compose is a declarative UI framework. You describe what your UI should contain, and Compose handles the rest. This way of writing UI is very different from Views. In this video, we'll cover the difference between the two and how you can shift your thinking to build apps with Compose.
So yeah, with Jetpack Compose, we no longer use XML views. It's a whole different method of building the UI, which it's aimed to be easier with less lines of code.
With Views, you describe step-by-step how to get your UI to look a certain way. You do this by defining UI in XML, finding views from XML in code, and then calling setter functions to get your UI to look the way you want. With Compose, you no longer have to write XML. UI can entirely be described in code, in Kotlin, taking full advantage of Kotlin constructs. Constructing UI by describing what, not how, is a key difference between Compose and Views. It's what makes Compose much more intuitive to work with. Let's take a look at a sample survey app called JetSurvey. The screen shows a single choice question the user has to answer. Once they make a selection, they can then proceed to the next question. To understand how to think about building this in Compose, let's first look at how we might build this using Views. To simplify things, we'll look at a single component in the screen, a single answer in the survey. This component is composed of an image, some text, and a radio button, all arranged horizontally. In Views, these elements would all be defined in XML. To populate the views with UI state, we would have to obtain a reference to each view in Kotlin or Java in our fragment or activity using findViewById. After obtaining references, we would then mutate each view by calling setter functions like setImage or setText to display the desired UI state. When state changes, for example when a user selects an answer, the view that was interacted with would appear selected. In our example, when a user selects an answer in the question, we also want the next button to be enabled. So if we want other views to update as a side effect of a view being selected, we would have to set a listener to that view and explicitly mutate other affected views. But having to manually update views when state changes is error-prone. It's possible to forget to update a view with its dependent state, and it's also easy to create illegal states when multiple updates conflict in unexpected ways. What if your app goes through a configuration change, like a screen rotation? And in the process, you might correctly remember the selection from the user, but you might forget to re-enable the next button. Synchronizing state changes throughout the lifespan of an app is a recurring challenge when working with views. This problem also increases in complexity as the number of views and dependent states grow in your app. It's a solvable problem, but it's a common source of bugs. Let's switch gears and see how we can think about building this component in Compose. In Compose, we would construct the UI in a similar fashion, in a container arranged horizontally with an image, text, and a radio button. Instead of writing this in XML, we would define our elements directly in code, in Kotlin. Doing it this way, we no longer have to jump between XML and code, as the UI would already be declared in code. In Compose, UI elements are functions and not objects. This means you can't find a reference to them and call methods to mutate them. Instead, UI elements are entirely controlled by the state or arguments that you pass. Here, we are just describing what our UI should look like. No calls to find view by ID, set image, or set text. Our UI is described succinctly in the functions we are calling. To display the UI state that we want, we're passing the answer's properties to the image function, to the text function, and for now, let's just pass false to the radio button function, which shows it as unselected. Another important distinction here from views is that tapping this answer will not show the item as selected. This is because we're always providing false to the radio button, meaning that it will stay unselected regardless of user interaction. Unlike in views, the radio button doesn't hold its own state that automatically changes due to a user event, but rather, the radio button state is controlled by the values that are provided into it. This is what we mean by what, not how. We're declaring what our UI should look like by providing the necessary state to our UI functions, but we're not telling Compose how it should render that state. So if state controls the UI, how do we go about updating state to update the UI? In Compose, we do that through events. When a user interacts with a UI element, the UI emits an event, such as onClick, and the event handler can then decide if the UI state should be changed. If UI state changes, the functions, or UI elements, that depend on that state will be re-executed. This process of regenerating the UI when state changes is called recomposition. The process of converting state into UI and state changes causing UI to regenerate is at the core of how Compose works as a UI framework. Let's revisit our example and update our implementation so that the radio button gets toggled when it's clicked. First, let's define a Boolean variable called selected and pass that into the radio button function argument. Next, in the onClick event handler, let's change the selected value to be the opposite of its current value. This way, when it's clicked, it toggles the selection state. With this change, we should now see the radio button being toggled when clicking on it. Notice that I left out the implementation of the selected variable because for this to work, we have to use a special state object, which we'll cover in the next video. In a production app, the state of the radio button should come from the answer state object, but we kept it like this to showcase how radio button state works. To summarize, to think and compose, we declare what we want our UI to contain, but we don't tell it step by step how to do it, unlike views. We use Kotlin functions to represent our UI elements, we pass in state to control UI, and we use events to update state, which in turn updates our UI. This was a really high-level overview of how to think and compose, but there's so much more to learn. For instance, how do these Kotlin functions work? What does state look like? What are the different components provided in Compose? We'll answer those questions in the upcoming episodes. Check out the resources below to learn more. If you like this video, go ahead and like, share, and subscribe to the Android Developers channel to see more videos on Compose. I'll see you in the next episode.
Alright guys, that was the first video that we're taking a look at today, and a good takeaway is what, not how. They want us to think what, not how, when developing in Compose, which is a bit different from using the layout. But now that we are, more introduced to Compose, Android wants us to continue making our projects in Compose over layouts now, but you'll see a lot of past projects are written in layout, so it's good to know both. But it's right now the consensus is to make your UI in Compose when possible. So the next video that we're going to look at is going to be composable functions. And so, yeah, let's go ahead and check it out.
With Jetpack Compose, you describe your UI in Kotlin as functions. No more XML needed. Let's dive deeper into these functions and how you can build UI with them. Let's see how we can build a single choice question screen of Jet Survey, one of our Compose samples. Earlier, we saw that a single answer in the survey can be written in Compose as a function containing a row with an image, text, and a radio button. To create a UI component in Compose, we must annotate a function with the @composable annotation. This annotation tells the Compose compiler that this function is intended to convert data into UI, so an answer into UI. Functions with this annotation are also called composable functions, or composables for short. These functions are the building blocks of UI in Compose. It's quick and easy to add this annotation, encouraging you to break your UI into a library of reusable elements. For example, if we wanted to implement a list of possible answers to select from, we can define a new function called single choice question that takes in a list of answers, and then call the survey answer function that we have just defined. This composable function accepts parameters, which allows it to be configured by the app's logic. In this case, it accepts a list of possible answers so that it can display these options to the UI. This function doesn't return anything, but instead, it emits UI. Here, it emits the column layout composable function that's part of the Compose toolkit, which arranges items vertically. Within this column, it emits a survey answer composable function for each answer. Composables are also immutable. You can't hold a reference to them, like holding a reference to a single answer, and later update its contents. You need to pass any and all information as parameters when you call it. Notice that since this function is in Kotlin, we can use the full Kotlin syntax and control flow to produce our UI. Here, we're using for each to iterate through each answer and call survey answer to display them. If we want to conditionally display something else, it's as simple as using an if statement. No view.visibility equals gone or invisible needed. You just call the composable if it needs to be displayed. This function is also fast and free of side effects. It must behave the same way when called multiple times with the same argument, and it shouldn't modify properties or global variables. We say that functions with this property are idempotent. This property is necessary for all composable functions so that UI can be emitted correctly when functions are re-invoked with new values. Notice that the parameters provided to the function entirely control the UI. This is what we mean by transforming state into UI. The logic in the function will guarantee that the UI can never get out of sync. If the list of answers changes, then a new UI is generated from the new list of answers by executing this function again and redrawing the UI if necessary. This is called recomposition. Recomposition happens when a composable is re-invoked with different function parameters, but it can also happen when internal state in the function changes. For example, say the survey answer composable accepts a parameter if the answer is selected or not. Initially, no answer is selected. In the view world, interacting by tapping on one of the answer UI elements would visually toggle it. But in Compose, since we passed false to all survey answer composables, all answers would remain unselected even when tapped. We need to make the composable recompose whenever the user interacts with the UI. To do that, we need a variable that holds the selected answer. But this isn't enough. We also need to be able to tell Compose that when this variable changes, recomposition should happen as well. To do that, we need to wrap the answer in a mutable state object. A mutable state is an observable type that is integrated within the Compose runtime. Any changes to the state will automatically schedule a recomposition for any composable functions that read it. To create a mutable state, we can call the mutable state of method. Since no answer will be selected initially, we initialize this to null. We also need to update the value of isSelected to compare the current answer to the selected answer. Since selected answer is of type mutable state, we have to use the value property to get the selected answer. When this value changes, Compose will automatically re-execute the survey answer composable so that the selected answer is highlighted. Creating a state object also requires that it be called within a call to remember. This guarantees that the value is remembered and not reset when the composable recomposes. With what we have now, while the UI survives recomposition, it won't survive configuration changes. To remember values across config changes, we can use remember savable. Right now, the type of the variable is a mutable state. But we can use Kotlin's delegated property syntax by using the by keyword. Doing so changes the type of our variable to an optional answer. This syntax is nice as we can work directly with the value of the underlying state. No more calls to the value property on a mutable state object. With our newly introduced state, we can pass a lambda function for the onAnswerSelected parameter so we can perform an action when the user makes a selection. In the definition of this lambda, we can set the value of selected answer to the new one. If you recall from the previous videos, events are the mechanism for how state is updated in Compose. Here, the event onAnswerSelected would be invoked when the user interacts by tapping an answer. The Compose runtime automatically keeps track of where state reads occur so that it can intelligently recompose composables that depend on that state. As a result, you don't need to explicitly observe state or manually update the UI. There are some other behavioral properties of composable functions you should be aware of. Because of these behaviors, it's important that your composable functions are side effect free and behave the same when called multiple times with the same argument. First, composable functions can execute in any order. Looking at the code for a composable, you might assume that the code runs in order, but this isn't necessarily true. Compose can recognize that some UI elements are higher priority than others, so those elements might be drawn first. Say, for example, you have code that draws 3 screens in a tab layout. You might assume that the start screen is executed first. However, these executions can happen in any order. Composable functions can also run in parallel. This lets Compose take advantage of multiple cores, which improves the rendering performance of a screen. In this code snippet, the code runs side effect free and transforms the input list to UI. But if the function writes to a local variable, such as in the snippet, this code is no longer considered side effect free and may result in odd behaviors in your UI. Recomposition skips as much as possible. Compose does its best to recompose only portions of the UI that need to be updated. If a composable doesn't use the state that triggered recomposition, then it will be skipped. In this snippet, if the name string changes, the header and footer composables will not be re-executed since it doesn't depend on that state. Recomposition is optimistic. This means that Compose expects to finish recomposition before the parameters change again. If a parameter does change before recomposition finishes, Compose might cancel the recomposition and restart it with a new parameter. Lastly, composable functions might run frequently. This might be the case if your composable function contains an animation that needs to be executed for every frame. This is why it's important to make sure your composable functions are fast to avoid drop frames. We covered a lot, so let's do a quick summary. You can create composable functions by using the @composable annotation. It's quick and easy to create composables, encouraging you to break your UI into a library of reusable components. Composables can and should accept parameters to configure their behavior. Mutable state, remember, and remember savable can be used to store a component state and have compose automatically track and recompose changes. And composables should be side effect free. We also learned about some interesting properties of composable functions. Composables can execute in any order, run in parallel, be skipped, and run frequently. The Compose Toolkit provides a lot of foundational and powerful composables that help you build beautiful apps. That's what we'll cover next. If you want to jump ahead, check out the links in the description below. Otherwise, make sure to hit subscribe so you don't miss the next one. Stay tuned.
All right, and so that dove a little deeper into composable functions, and this should help us to gear up for the next lesson where we're going to be diving more into composable code. And so for this live stream, that's what I wanted to expose you all to were these two videos so that you can be able to digest that portion before we go too much further. And yeah, if you want to go back over the videos, you can either by visiting that link I shared, or you can go ahead and rewind this live stream to take a look at them again. And so that's what I have for you all today. Thank you so much for watching, and as always, stay coding.